So for problem 16 and problem 17, we're looking at the greatest integer function. However, can you please go ahead and cross out problem 17? We are not going to do problem 17 in here. You can put an X on that. And you can also write the word omit if you want, because we are not worried about this one in here for academic. All right, but we are certainly looking at problem 16. So please pay careful attention to the greatest integer function, especially for translations, because it would be impossible to tell what the transformations were unless I had this indicator right here. That is the only way I know where it starts. I have g of x pointing to the first step. And remember, it's also called a step function because it creates little baby steps here. All right, so I certainly know that this has been translated one place to the left because it is no longer on the origin. It's one place to the left. It is no longer on the origin. It is also 2 places above. So I know what H and K are. H is 1 place to the left. K is 2 places up. Any questions on how I knew that transformation? I only knew that transformation because g of x is pointing to the first step. So now that I see this is 1 place over and 2 places up, I can now write my function. So we're going to call it g of x because that's what the instructions indicate. And remember, we're going to use those double brackets. And it is still opposite inside those double brackets, guys. So even though it is 1 place to the left, remember, we're going to write +1 here inside the double brackets. And don't forget your k value of +2. And that's going to tell me it's 2 places above the origin. And that's how you do the greatest integer transformation. Do you guys have any questions on that? We are on page 44. So let's go ahead and take a look at the next part here, guys. And the next part is writing equations from absolute value graphs. So just so you know, we are going to cross out 21. And the reason why we're crossing out 21 is an ugly graph. We don't do ugly in pre-calc, so don't even look at problem 21. But we are going to do problem 20. So we're going to be writing the equation here. The first thing that we need to look at is HK, guys. And for this example right here, HK, what is the ordered pair for that vertex? Perfect, 8, 0. Let's write that. Now remember, in your transformation equation, we're going to drop H in the group, but it's going to be opposite. So I am going to go ahead and write g of x equals. I'm going to draw some absolute value bars, and remember it's going to be x minus 8 inside of those absolute value bars. Now, usually I do leave space right here in front of the absolute value bars because sometimes there is a vertical stretch or a vertical shrink, and you always have to check for that. I'm going to show you why I know there is not a vertical stretch or a vertical shrink. If I go over 1 place, 1 unit, and it doesn't even matter the scale of the graph, as long as I go over and up the same distance and land on the graph, there is no vertical stretch or shrink, because remember, for absolute value, and if you guys look over here, I wrote it on the whiteboard yesterday, I just wrote it on this graph paper over here. Absolute value is a 1-to-1 relationship. I went over 1, I went up 1, there's no stretch or shrink. So I know I do not have any A value in front of the absolute value bars, so this is the correct answer. Let's take a look at problem 22. Problem 22 has been translated to the left and translated down. How many units to the left did it go? 4. So I know the h value is negative 4. What's the k value? Negative 8. Good job. So again, this is going to be g of x, and I just want to make sure that there are no stretches or shrinks. So again, guys, if I go over 1 unit and up 1 unit, I do land on that graph. So I know there is no stretch or shrink. I am good to go ahead and write x plus 4 in the absolute value bars, and then of course minus 8 on the outside. Okay, let's take a look at this next one, number 23. Number 23 looks like it might be tricky, but it's not. And the reason why I say it might be tricky is because it has the h value kind of floating in the space. But if you guys notice your tick marks here, every increment is by 2. So if this is halfway in between 0 and 2, then I know my h value is going to be a positive 1. What's the k value? Very good, negative 2. Now again, even though it's a halfway mark, I just want to show you there is still no stretch and no shrink. I went from 1/2 to the next 1/2 mark, which is 3. And notice when I go up, I do land on the graph. So we're going to have g of x equals x minus 1 in the bars, and then minus 2 on the outside. That's how we're going to write those graphs, guys.